you just do it, it'll turn out okay. And Doc Dino is back after his field trip. Or
I've been on a little bit of a hiatus, but hopefully this marks my grand return to YouTube, I guess.
so anything you can you share anything about your work, or is it still confidential?
Well, I mean, I can say I'm doing a lot of stuff for my local museum these days, remaking a lot of displays, and, well, I'm reporting my finds. Next week, I'm going to be taking some Bureau of Land Management agents out to look at my fossil sites. And, well, hopefully, at least next year, can maybe start getting some of them dug up. But I'm also thinking of going back to school, so I guess we'll see where life takes me.
Mm, nice. So,
Right. Well, I guess might as well get started a little bit here. For those of you who have not seen this series before, this is a little series where Vandalia and I go through the tree of dinosaurs. So far, we've talked about all of the ornithischians, so most of the plant-eating dinosaurs, and at least the origins of a lot of the meat-eating dinosaurs. We've also talked about the origins of the sauropods, but we've not followed them to their end. And that's what we'll be going over today. We're going to be going from when the sauropods first start getting big to when they get really weird, and then when they get really big.
yeah. You know how in giraffes, how they say that vein, what's that vein called?
Um, are you talking about? Are you talking about the recurrent laryngeal nerve?
Yeah, the nerve. How it stretches all the way down there. That's nothing compared to what sauropods had to deal with, probably.
Oh no, it's absolutely absurd. For anyone who's not familiar, there is a nerve in all tetrapods that goes from the brain, loops around the aorta. I believe it's the aorta, and then it loops back around to the larynx, so your voice box. So every time you talk, that impulse has to travel down to your heart before it can reach your voice box. In giraffes, that line is, I believe, over 10 feet long, maybe closer to 12. For some sauropods, it would be well over 60 feet in length. Just one nerve, just so they can make noises with their throats. It's kind of ridiculous. But that's biology. Biology works with what it has. And back when tetrapods were fish, a little divot like that wasn't a big deal. But then we got necks.
And you can only adjust. You can't snip and fix.
Nope, biology can't exactly start from scratch. It can only work with what it has. And that's what it had to start with. But
So
fortunately, we're not going all the way back to fish today.
speaking of starting, where did they start? Where did these guys start at?
The sauropods? Well, the earliest sauropod ancestors we have go to about 230 million years ago. So, uh, the beginning of the late Triassic. In the span of about 10 million years, they go from these little long necked weirdos to these big long necked weirdos with
And
massive
and went from
claws.
bipedal back to quadrupedal.
Um, so the weird thing is they get big before they become quadrupeds, but as time goes on, it seems like they did become quadrupedal. Yeah, and we'll kind of go over that transition a little bit. For those who have seen the series before, you might recall a very old episode where we talked about the origins of the sauropods, and we covered that transition in detail. This time, we'll just give you guys a little refresher course. With that said, we are also going to be joined today by my friend Dominic. Uh, Again, if you've seen the series before, y'all might recognize him. He's he has been a fossil prep intern at places like Harvard, and he's trying to go to other places. But he's running a couple minutes late, but we won't hold that against him. It happens. He will be here soon. And and yes, as Eddie McCoy says, sauropods are also called longnecks. And well, shall we get started, Vandalia?
Yep.
All right. And really quick, I do just want to shout out this beautiful piece of art by El Reptiliano from Twitter. They do a lot of really good stuff, and I really love their art. This piece was inspired by um, an episode of Prehistoric Planet, which is a documentary we've only mentioned a few times in this series.
So do we know what's clade or species or genus these on the screen are?
I believe these are a genus called Dreadnoughtus, which is one of the larger sauropods and actually has a pretty cool name. They are named after the type of ship, a dreadnought. Because I think it, to paraphrase the person who named it, it's about time herbivores got the credit they are due, and this herbivore would fear nothing.
Yeah.
Anyway, let us begin. So, quick review of Sauropoda, just the whole group. Like all dinosaurs, sauropods started from pretty humble beginnings. The ancestral sauropods were dog sized, such as this one, the Brazilian Saturnalia, which, fun fact, is named after the Roman festival because it was discovered during Carnival, which I just think that's kind of funny. But throughout the late Triassic, as we mentioned earlier, they absolutely exploded in size. There is very little difference in time between Saturnalia here and Plateosaurus, which is one of the largest bipedal sauropodomorphs. And by the time we reach even the early middle Jurassic, the Cetiosaurus here and the Lesomsaurids, they just get absolutely massive. The biggest of these guys was the size of about the largest African elephants alive today, and they lived less than 30 million years after Saturnalia. And Cetiosaurus here was less than 30 million years after them, and we're already getting to multiple African elephant size.
And those are the small. And those are the small ones.
Yeah, Cetiosaurus is about on the smaller side for a mid-sized sauropod, which is kind of crazy to think about. And of course, by the time you get to the biggest sauropods, it just gets kind of absurd to use humans for scale. These are some of the largest known titanosaur sauropods, and to call them immense is an understatement. You can see some of these up here are estimated at like 40 meters long. For some, that might be an underestimate, and weighing up to, if not over, 100 tons. And today in this entry, we're going to break our format a little, and we're going to talk about how they evolved to get as big as they did. Because sauropods really stretch the rules of biology to their absolute limits just to survive. Also, I do want to shout out really quick. Thank you, Lethargo Peterson, for gifting a Dr. Dino membership to Wayne the Scene. Thank you very much. I will say, for anyone who is watching on my channel, I do have a super chat goal. If we reach that goal, then I'll do another fossil hunting vlog, which apparently you guys liked last time, and I enjoyed putting them together too. These presentations take quite a bit of time to put together, so if you want to send a tip via a super chat or Venmo, it's highly appreciated.
Yep. I also have a goal, not a thing, but I can hire a book coach for my book.
Oh, fun. Anyway, sauropods were basically, without question, the largest land animals of all time. And, well, when someone says sauropod, you probably just think of a generic long neck. They were actually pretty diverse. They got kind of freaky, to be honest with you. We're going to see some of that diversity today.
Like health, like do we need to? Can we talk about? Do we need to censor how freaky they're getting on this channel?
No, we'll be fine. Anyway, sauropod variety more than meets the eye. So, like I said, usually in pop culture we just see these as long-necked browsers, but there really was a wide variety of sauropod body plans and ecological niches. There were towering tree cutters, far-reaching lawnmowers, and short-necked little weirdos that we'll get to in a little bit. Wherever they went, sauropods filled basically every herbivorous niche they could. And more often than not, they were the largest herbivores in their environment. Adults would basically be untouchable to all but the most foolhardy predators, basically.
Did any of these go carnivore, or were they all herbivore? With some omnivore, obviously.
That's a good question. Some of the early sauropodomorphs, like Saturnalia, would have probably been omnivores. But basically, once they start getting big, all of them seem to have been herbivores. Not to say they couldn't snack on meat every once in a while, but it's very unlikely any sauropod, or at least true sauropod, hunted actively. They would have been too big and too slow. But then again, deer will eat meat if they find it, so you never know. But while the adult sauropods were giant, invincible titans, that's not really true for the juveniles. The juveniles would have been really small and basically defenseless. So, how did sauropods reach those gigantic adult sizes if they started out so weak? Well, fortunately, the fossil record doesn't show us everything. It does give us some clues. See, like any dinosaur, sauropods were born from eggs. The largest known sauropod eggs are less than a foot across. In fact, most of them are closer to 8 or 9 inches. But the adults that laid those eggs could be anywhere from 50 to 130 feet long. So, how could they pass through those vulnerable early years and grow to their adult sizes? Well, there's two major answers to that question. First, be born with a ton of siblings and grow up fast. There are some preserved sauropod egg sites, like one called Alcamoevo in, I believe it's either Brazil or Argentina. But these sites suggest that sauropods nested in these gigantic colonies. There would have been dozens or hundreds of individual adults laying dozens of eggs each. And all of these eggs would have hatched at around the same time, meaning just a huge swarm of baby sauropods would flood the nearby area. And if there's, say, 3,000 or 4,000 of these things being born every year, it's going to be hard for the predators nearby to eat all of them.
Yeah.
Even if only 1% survive to adulthood, that's still at least 30 or more elephant-sized animals or bigger surviving to adulthood to pass on to the next generation.
So how big were these eggs? Like bird eggs, like bird eggs today, or ostrich eggs, or robin eggs?
The largest ones are about the size of a soccer ball. Which, I mean, that you hold it in your hands, that feels big, but considering the adult size, that's absolutely tiny. And actually, here we have a little baby sauropod. Uh, I don't want to say figurine, kind of a nest diorama from the American Museum of Natural History.
So
And
no time travel here. Going back in this is a Polaroid of past
sadly,
time.
no. But it was super cute, and I just kind of had to include it.
Yes.
And this is pretty much what they would look like when they were born. If you want another good look at baby sauropods, check out season 2 of Prehistoric Planet. There's a whole sequence about some baby sauropods being born and escaping predators, and most of them get eaten.
Did you ever watch Land Before Time?
I watched the first 6 or 7 religiously growing up.
I actually did not know there was more. I watched the original growing when I was a kid, but I did not, maybe the second or third, but I didn't know there was like 20 of them or how many there is.
I think there's at least 12 or 13 now, probably more.
That's one of the
Um,
first deaths I ever saw on TV. The mom.
yeah, that one was really sad. Um,
Any,
sorry, getting back to this, I'm just noticing for some reason this figure is cut off. It shouldn't be. I don't know why that is. But this
any
little
about
graph,
being eaten, when you saw pod parents being eaten, being get eaten in our presentation?
I'm sorry.
Will any sauropod parents be getting eaten in our presentation?
Uh, I'm not. I don't remember off the top of my head, but I don't think so. And actually, about that, we don't really know how good of parents sauropods would be. Uh, kind of unfortunately. Uh, some people think they may have been really neglectful parents. Some think they may have been kind of there, but mostly just around their babies, focusing on eating. We're not really sure. But what we do know is as we go from more basal sauropods, which the axis over on this side is growth, by the way. I think I cropped this figure a little weirdly, but early sauropodomorphs had kind of stepwise growth, kind of more similar to a lot of more basal reptiles or like lizards today. But as you get into the more large sauropods, the growth just becomes constant and it explodes. Because, keep in mind, the first step to being successful as a sauropod is to have lots of siblings. The second way to be a good sauropod is to grow up fast. See, like other dinosaurs, sauropods had really high metabolisms, which is kind of weird to think about for such a huge animal. We're able to perform body temperature analyses on sauropods and other dinosaurs thanks to their teeth and preserved eggshells. Uh, See, when you're a warm-blooded creature, sorry, reminding a bit. See, depending on the temperature of your body, minerals inside your body will crystallize with slightly different isotopes of different elements. These mostly being oxygen and hydrogen and nitrogen. And that's just because different isotopes of different elements react differently at different temperatures. So you can get a slightly different proportion of one isotope to the other in an animal with a higher body temperature. And using that principle, we can estimate the temperatures of extinct animals using modern ones as an analog. So if you look at this study here, and the graph's kind of weird. This side is logarithmic, so this is body mass. This is a body mass of 10 pounds, 100 pounds, 1,000, 10,000, etc. And then we have body temperature in Celsius. So you can see we have modern birds up here, most of them being under 10 pounds, but there's a temperature range of about 37 degrees Celsius to 46. And over here, we have a bunch of different sauropods with this little blue cross here. And the body mass ranges from about 10,000 pounds to 50 or 60,000 pounds. And the body temperature goes from about 30 degrees Celsius to about 45, meaning that at least some sauropods had a body temperature overlapping with modern birds, which suggests that they had a really high metabolism. Which, again, is kind of crazy to think about for such large animals. These things burned calories as fast as birds. So, how much do you think they ate? But anyway, based on information such as this, as well as studies of the bones, such as studying growth rings, lets us estimate how much weight a sauropod would be putting on every year of its life. And for smaller sauropods, this usually winds up being about 1 ton a year. Now, that's a small sauropod, meaning a year-old sauropod would be about the size of a huge bull.
Now, these guys had like, I'll say bird bones, but hollow bird type bones, like not solid bones.
They had very holey bones, except for the legs. The legs were actually very solid to help support their weight. But otherwise, yeah, they were very airy, very pneumatized. Also, it looks like Dom is here. If you would let him in.
All right.
I joined it at the perfect time. They're awful,
Yes.
awful growth.
Yes, hello, Dom. Do you want to give a brief introduction for the people?
Yes, leave me 2 seconds while I fix my mic because it's probably very quiet. So.
You sound fine to me.
Now I probably sound better.
You're all right. Quick introduction for the people.
Hi, my name is Dominic. My name is Dominic. Dominic P. Dominic Peary. Blah blah blah. I am hopefully in the future something of study up in the air currently, but I am now officially going to be going back to college to studying for a biology degree.
Oh yeah.
Zookeeping, zoology, or paleontology, something of that sort.
You might want to tilt your camera down, Dom.
Yeah, I forgot my name.
There you go. That's great.
Yes.
Let's see. What do you have about sauropods possibly putting on 4 tons of mass every year of their lives?
These are evil creatures. For reference, by the way, I looked it up beforehand, but I'm double checking myself. Whale growth for the largest. Actually, we can use elephant growth. Elephants, I think, take like 10 to 15 years to get to maturity.
I think so. And they usually they get to like 10,000, 12,000 pounds at most.
Yeah, which is, if I remember correctly, how old is a quote unquote mature sauropod? It's 10.
Most of them never stop growing, but I think their growth slows down after about 15 years.
15. So that's
of course. Then again, unlike elephants, sauropods don't need to carry their babies to term.
Well, no, there's that. Sauropods start a lot smaller than elephants and get a lot bigger.
Yes. Again, keep in mind these eggs down here are smaller than a football.
Yeah.
But those babies could put on over 1,000 pounds in 1 year. Some of them over 8,000 pounds in a year, depending on the species.
You could
And
that
is 1 year. That's more than 20 pounds a day.
Now I'm wondering now, if sauropods were live birthers, how long would they carry? I think elephants like 2 years or something like that.
Elephants is 2 years. Blue whale is almost 4 years. They would probably be very similar to how whales do it, which whales, I believe it's 2 to 4 years on average. I know they also birth significantly for the size of them smaller babies than other mammals. But
Well, I mean, keep in mind, sauropods would have to really remodel their pelvis in order to be able to do live birth. So,
correct.
without changing the pelvis, a sauropod baby would still be small, but probably bigger than the eggs are that we know of.
They would also probably wouldn't be as big. Part of the reason why sauropods are so big is because they're doing. You mentioned that there are selected. That
Had a ton of babies, yeah.
yeah. 10 since they had so many babies, they could afford to be so big because they just keep producing a lot of babies and not taking care of them. So the parents can just kind of ignore them.
Probably. Or at least that's most likely, because an adult sauropod, even if its growth was slowing down, like I mentioned already, they had a metabolism comparable to birds.
It's just these are awful animals. But yeah, actually, the great sentence: a herd of baby sauropods would probably be very similar to plagues of insects. They got the horror for if they were alive today. A farm would be gone in a day or two, just gone,
Just a
literally
huge herd of
annihilated.
them devouring the African savanna.
Yeah, exactly. If you've heard how bad elephant herds are in Africa for farms, they can go through a farm in a day or a few hours. Baby sauropods or young sauropods would be that on steroids.
Yeah. And growing at 2 or 3 times the rate of an elephant, too. I,
Correct.
So
I
you're
don't know what the estimate is, but sauropods would spend the vast majority of their life eating.
70
They
to
would probably
80%.
not sleep for more than an hour at a time,
Yeah.
so
just
you're
so they could
saying
keep
they wouldn't
eating.
survive for a year on a boat then?
They wouldn't survive a week.
If you have one baby sauropod on Noah's Ark, half of the rest of the ark would have to be filled with plants
Correct, yes.
for one
Sauropods
baby sauropod.
ate so much food. They would eat so much. These are the type of animals. If you ever heard that there are some animals, especially for aquatic animals, that you just can't keep in captivity because of certain things. Sauropods, at least, hell, even the small ones would be really hard to keep in captivity because of how much food you would need to feed them.
Yeah. And not to mention, like, they would always have an urge to migrate because they would have to survive.
Yes. So these would be animals again. They'd be very similar to keeping whales in captivity. Actually, the reason why no whales are in captivity is one, space; two, whales constantly migrate and aren't sedentary; and three, especially baleen whales, the food intake.
Just absolutely incredible amounts of food.
Yeah.
Oh, super quick. Did get a super chat, and then I have to go use the restroom. Thank you for Vanzi Jessica Manda for $20. No message. If you send a message, we will highlight it. So thank you very much. Dom, would you be okay taking the next slide while I use the restroom quick?
Yes, and let's see what the next slide is so I can take it. Oh yeah,
Sauropod
this.
life.
Sauropod life is very simple. Sauropods were probably some of the least intelligent dinosaurs, just due to how small head to brain size, blah blah blah. They have their entire lives dedicated to two things: eat, move, or four things: sorry, eat, move, mate, sleep. That's it. Now, of course, they play. All animals play. Then do some blah blah. But sauropods wouldn't have the brain power to do much else, and wouldn't have, and their metabolism would require them not to do not much else. They need to be constantly eating, constantly on the move because they're eating all of the food, and because they are selected, they have a bunch of babies, constantly looking to produce their genes, because not many of their young would survive. That's how our selected animals work. We also have plenty of trackways showing that one, they do probably live in age segregated groups. So we have, I think there's trackways of baby diplodocids together. There's trackways of, I think it's the titanosaurs, all adults moving together, which makes sense. These animals, the babies, probably all stages of life, they're eating different plants at different height ranges. Also, an adult sauropod would probably accidentally kill a lot of the younger ones because they couldn't see it and don't have the brain power to look over where they're moving. Or even accidentally, if you've ever heard of the death traps in China, where sauropod footprints in mud would step down and go like 9 feet. And we found many graveyards of smaller dinosaurs in these pits. And baby sauropods just fall in them. So these are constantly traveling, constantly eating, probably like once or twice a year, mating. And hell, this is speculation, maybe for later on, but sauropod hatchings were probably like salmon runs for some dinosaurs, where it's these constant, like little fatty balls of meat, a bunch of them just hatching and moving, hundreds to thousands of them at the same time. Because we
Probably
also have
thousands at minimum. I want
sauropods
to say
all
there are at
nested.
least 100 nests at Alcamoevo, and
How
that's
many
only one
nests?
site.
I think there's hundreds of nests at the Isosaurus nest in India too.
Yeah.
So these dinosaurs, sauropods are probably keystone species. Like most of them were probably keystone species.
Just a pillar of the ecosystem.
Well, they probably also spread plants because of how many they ate. Like in the Cretaceous, these things are probably also eating fruit. They are probably some of the sole reasons why some plants spread. Because they're probably repeating the same path back and forth. They're probably literally eating the plants that they planted from years past constantly.
I mean, I wouldn't be surprised. Sauropod dung would probably be pretty good fertilizer.
Yeah, and there's a lot of them. So
were these guys on both Gondwana and Eurasia?
They were
yes.
everywhere.
Everywhere
We'll talk about it, or we'll talk about it a bit more later. There's a weird hiatus of sauropods from North America during the Cretaceous, but otherwise, they are all across the globe through the entire Mesozoic.
Yes, they are the longest running. I'm ignoring just base Theropoda and Ornithischia. They're probably the longest running group of dinosaurs.
I mean, it's kind of hard because sauropods are split up into different clades.
Yeah, that's true. But
I know that some of the oldest dinosaurs known that are assignable to a group are sauropodomorphs, like Eoraptor's a sauropodomorph.
Exactly. So sauropods were probably some of the first dinosaurs that evolved to be herbivores.
And as far as we know, there are no living sauropods today.
Definitely not.
Definitely not. We would know if there were.
We would find a destroyed forest.
Just a flattened forest floor with baby shoots left in their wake.
Again, they're also yeah. The other thing with sauropods, I don't know if we might get to this later, but sauropods are like some of the dinosaurs that it's hardest for the human brain to even comprehend because they're just so different from anything that lives today. Like hadrosaurs and ceratopsians, your brain can kind of imagine them as like a horse or a cow analog. There's no analog for what a sauropod is. You say giraffe, but giraffes act more like other ornithischians because they raise their young, which most ornithischians probably did. The closest thing would be a sea turtle, and sea turtles act very differently.
I'm going to take down the screen share for half a second. just because I have to change something. You guys can keep talking. I just got to edit
Yeah,
something into.
before you got on, we were talking about giraffes and their neck and sauropod necks nerves. How they make giraffes to shame.
Sauropods are, in my opinion, the only correct way to make a long neck. Every other way an animal does it is wrong and awful. I don't know if Doc mentioned that, but mammals do awful things, and they don't add more vertebrae. They just make their vertebrae disgustingly long because, as a mammal, unless you're a sloth or a manatee, you have 7 vertebrae. Manatees have 6, sloths have 9.
Yeah.
And a plesiosaurs or something worse, which is called just make more vertebrae until you have 72 in Albertonectes.
Well, the thing is, like some plesiosaurs do both.
Which is still awful. Sauropods are the only ones that are fine because they slightly elongate it and make slightly more. So they have like 10 what? I think most of your sauropods like 13 or 14.
No, it's more than that, at least in like Mamenchisaurids. I think it gets up to 20 or so, but I could be
It's
wrong.
fine. 20 is fine. 72 is too much. And 7 is too little.
But at any rate, the sauropod life was definitely an interesting one.
They probably did the same thing every day for their entire lives. Well, plus playing, of course. There's
At
also the
least as
chance,
babies.
yeah, also a chance that some of the smaller sauropods are probably smarter and had more like complex social structure. But we also don't know that because there are some very dumb animals like fish that have very complex social structures. So
Yeah. I mean, instincts can do a lot for you.
exactly, and sauropods probably have really good instincts. Actually, if you don't have this in here, there's one thing with instincts, which is nerves. Do you have the nerve thing in here or no?
I do not.
I'm going
But
to
we
mention
can probably talk about that when we get to
Diplodocids.
the longer sauropods.
Yeah. We need to talk. The nerve thing is awful. We'll get to that.
We'll get to it. For now, let's get a little lightheaded. Because kind of a weird thing with sauropods, when you try and model their mass, a lot of estimates come out as much lighter than it would be if you were estimating the mass for a mammal. And that's because, well, if you recall, sauropods had a bird-like metabolism, and with that metabolism came a bird-like respiratory system. They had air sacs that filled vacant areas in the body and went into almost all of their bones, except for the limb bones, which kind of had to be solid in order to keep their weight.
Yeah.
And thanks to those air sacs, and well, also just their bones are incredibly holy, and that's holy with an E before the Y. Right here, you can see an Apatosaurus neck vertebra, and I believe this is a swan neck vertebra.
Yes.
Both of these went through its CT scanner. The sauropod neck vertebra is almost, if not more holy than the swan, a literal bird.
These things are made of air and nothing else.
Or at least their vertebrae are. Just
yes.
they're air.
Well, swans are mere theropods, not.
But they're flying theropods.
They're
and some of
flying.
the larger flying theropods too.
They're flying, which is the main issue. Yeah. So besides their limb bones, which are incredibly thick, from what I understand, mind you, they're also thick because they're big. Sauropods are built like paper mache.
Yeah. Basically, anything above the hips and shoulders is just, it is paper mache. And to illustrate that, I'm going to show a dinosaur and a mammal. One of the largest mammals known. The weight estimates for both of these animals is the same, 15 to 20 tons.
Yeah.
That's how much less dense a 20-ton sauropod is compared to a 20-ton mammal.
I think we talked about this earlier, but I talked about this with Doc earlier by themselves. Dinosaurs are not very dense. Even the most dense ones are ankylosaurs. Or, ankylosaurs are pretty dense, but
Either ankylosaurs or Lurdusaurus, which is an outlier.
Lurdusaurus is an outlier. But
Some large theropods also get pretty dense, weirdly enough.
yes, but like for example, mammals are also really dense for no reason. It's just we go on a mammal thing because we study mammals the most common. But like a good example is Doc and I came up with an example earlier as well with a polar bear and Utah raptor, which weigh the exact same about. And one of them is 7 to 8 feet tall and 20 feet long. One of them is 4 feet tall and about like 8 feet long.
I think 9 feet for large males.
Yes. And polar bears weigh a ton. And so dinosaurs are excessively light, especially sauropods. They seem to do the thing. It's why they get so big, but it seems that all dinosaurs do this, even like the smaller ones. It's just how they're built. They're built to be light. So unlike mammals, which are kind of built for power, it's why a lot of dinosaurs probably were long distance runners, while a lot of dinosaur predators and even dinosaur herbivores, well, a lot of mammals are sprint runners, and mammals have to be well adapted to be endurance runners, where the opposite's true for dinosaurs.
Yeah. And just in case anyone's curious, I had to cut out this outline of, it's called Paraceratherium. Before I cut it out, these figures, like for scale, were the same exact height.
Yeah.
So this is just how big these animals were.
Yeah, and they're the same exact weight. It's awful.
Like pixel to pixel, they were both 141 pixels tall.
Yeah.
It's dinosaurs are not dense.
No.
There is a reason why mammals will never get as big as a sauropod.
Yeah. The closest we get is Paraceratherium or Paleoloxodon, and it's literally only those two that get anywhere close to as big.
Unless you go underwater.
If you're underwater, underwater has weird things. Again, we haven't found a semi-aquatic dinosaur yet. When we do, it's going to be awful. Or sorry, a properly full aquatic dinosaur, I should say. Full aquatic. You have semi-aquatic ones, and that's also weird. So.
Also, Dom, I'm hearing you are kind of loud for some people. Is there a way to turn down your volume at all?
Give me 2 seconds. You should be able to. Audio. Apparently not. Show advanced options.
Dolly, is there a way for you to turn him down on your end?
Let me see.
Okay. Just checking.
Okay.
I might also just be loud because me, but.
Any better?
Hello, 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 hello.
Sounds quieter to me.
Okay. I'll also speak slightly quieter. I tend to be loud.
Sorry, someone told me. Anyway, yeah, dinosaurs get big, even though they weigh too much, which is kind of crazy to think about. And actually, speaking of whales, were sauropods whales or landlubbers? If you grew up in the 70s or 80s, then you probably remember a lot of sauropod depictions showing them being underwater, or at least very near to the water. And to be fair, when we first discovered them, I mean, they are whale-sized reptiles. Like, you figure they're as big as the biggest living things today. They probably lived like the biggest living things today. But since the 1800s, we found a lot of land-based trackways from sauropods, showing they were just fine on land. And also, modern math and computer modeling pretty well confirms that even the biggest known sauropods, they would have been just fine on land. And heck, this is a very classic painting by Charles Knight of Brachiosaurus. If a Brachiosaurus were to stand like this underwater, one, it would float because, as we've been over, dinosaurs are made of air.
Yeah.
But two, just the pressure on its lungs would have been so great, it wouldn't have been able to breathe.
Yeah.
Just, I don't know, kind of a historic thing, I guess, I kind of wanted to touch on because even when I was growing up, I had kids' books that had sauropods living in swamps
I had kids'
or
books
living
that said
in
new information. Sauropods no longer lived in the water, so it's a good thing to mention.
Yeah.
Just the history of them. So
And actually, speaking of swimming sauropods, in 2007, we discovered some traces of swimming sauropods. These were found in Glen Rose, Texas. There is a set of 3 individual trackways. Don't know if they were made at the same time, but could have been a herd traveling together. And it's a trackway that only preserves 4 feet. There are no hind feet in the trackway, which is kind of impossible to do if you're walking on land.
correct.
Were these trackways discovered by real people and not
Oh yeah, real people.
a certain museum
These
owner?
are not Carl Baugh's discoveries. No, these are real tracks. They were described by Robert Bacher and colleagues in 2007.
So it's definitely real if it's Bacher.
And yeah, Bacher is about as real of a paleontologist as you can get.
He is, by definition, the word paleontologist.
Pretty much, yeah.
If you looked up paleontologist in a dictionary, you'd see a picture of him.
Yeah, field hat and all.
Field hat, large beard, necklace with some sort of fossil on it. Wears a vest.
Probably holding an Allosaurus hand, because I think that's the most famous picture of him.
Yeah.
And the trackway revealed something kind of interesting. It seems that whatever sauropod made this trackway, it was probably paddling with its 4 feet, and in this case, its 4 feet were hitting the bottom of the water, and their hindquarters would have been floating in the water behind them.
Yep.
So kind of like a doggy paddle.
These are probably
which kind of makes sense if your entire back is made of air.
Correct. Also, sauropods are probably very good swimmers, like how elephants are really good swimmers, just because of how much water they'd be displacing with each kick. And even them touching the bottom in some cases.
Yeah. Not to say there couldn't have been any diving sauropods. There probably was some weirdo out there. And actually, later in this presentation, we'll be seeing some candidates for such a thing, but we haven't found them yet. Anyway, moving on. Now let's talk about how they walked, because we just said they walked on land. And keep in mind, when we started this presentation, we were talking about bipedal animals. And in fact, this is the hand of a Plateosaurus, which, I mean, you can kind of compare it to your own hand. This finger over here is the thumb, and you see the pinky and ring finger are really small. It's actually a fairly normal dinosaur hand, at least an early one. In fact, lop off these 2 fingers, and you could probably mistake it for a meat-eating theropod.
Yep.
So how did it become a quadruped? Their hands became a crime against nature.
No. Sauropods do awful things.
It turns out that somewhere between around 3 and 12 tons, they started to really struggle with being bipeds. And apparently broke their fingers or something in order to walk on all 4s. And that is exaggerating a bit. The first quadrupedal sauropods, we don't know what they were like exactly. The transition isn't covered very well by the fossil record. But they might have been knuckle walkers, is an idea.
I think we have some evidence for it it's not Ankylosaurus, it's one of the prosauropods. It might be Glacialosaurus.
I'm not sure.
One of the one of the later sauropodomorphs, it's like 10 tons, has evidence of weird development in their hands. I don't remember which though.
Maybe like Melanorosaurus
Yeah,
or not Lemusaurus, Lesumsaurus maybe.
Yes, that might be it. They have like weird hand things, but they still look pretty normal. I think they look similar to like anteater hands, which is a knuckle walker. So
yeah,
which is normal. And then they do awful things and turn their hands into bean flesh fillers.
Yeah. There is some point in sauropod evolution where they stop putting weight on their fingers and just go straight to the knuckles. And then they lose the fingers.
For some reason.
A lot of sauropods retain the thumb claw that their ancestors had, but in some later groups, even that is lost. And you just have a pillar of bone.
That's not...
Because the bones almost fuse, too.
It's also not shaped like an elephantine foot, where it's this trunk. It's shaped like a bean, which is genuinely awful. So instead of you think it's like this, or they're walking like this, no, it's like this. It's literally this shape how they're walking. You can see in the image.
But it's their metacarpals, not their
but it's their
fingers.
metacarpals, not their fingers. It's like if you removed my fingers, but it's still in this position of walking.
So not like how the Pterodactyls or Aerodactyls feet fuse together.
Artiodactyls, you mean?
Perissodactyls and artiodactyls?
Yeah.
No,
Yeah.
not like that at all.
No, no.
They walk
That's normal. That's normal. Sauropods do awful things. Their back feet also do weird things because they're also not just a normal flesh pillar.
Yeah, I don't have a picture, but they skew sideways.
Yeah, their back feet they kind of walk on the like the side of their feet, but then develop flesh so they can do that for some reason.
Their feet are just awful. And if you ever look at a sauropod in a movie, they never get the feet right.
Which is fine. Or what they do in like the most recent movie, Jurassic World Rebirth, they hide the feet, which is the correct decision.
It's just, they're terrible creatures.
If you want to see an accurate depiction of this feat in any sort of media, go watch the Dreadnoughtus scene from Prehistoric Planet. They have the best way to... Technically, all the sauropod feet in that are fine. The Dreadnoughtus are the best shown. One, because it's a flat plane, and two, because they rear up. So you can see their awful feet. Yeah. No, sauropods...
Yeah.
Now, probably the reason why their feet are very strange compared to other larger animals is because, one, they were bipedal, unlike artiodactyls and even aphrotheers.
Ancestrally.
They're ancestrally bipedal. And two, they were probably bipedal for a lot longer than other things were. So they probably evolved to compensate their weight while still being bipedal, and then transferred to being quadrupedal while they were already gigantic, or at least big for our standards, which is why they're so weird. Because even their leg bones are a bit weird because they're really, really thick.
Yeah.
Yeah.
But I mean, they're just really weird animals. Yeah,
it's strange. Oh yeah, there's this too.
Oh, good. Did you want to say something else?
No, we're good. We're good.
Okay. I did want to bring this up too. If anyone here has kind of kept up with dinosaur reconstructions in the last 20 years, you've probably noticed a kind of change with a lot of sauropods. Back in the early 2000s, when Dom and I were growing up, this is what a lot of sauropods looked like. They were very horizontal with sloping backs, and their necks were kind of just straight out ahead of them.
Yep.
We don't think they look like this anymore, for a few reasons. In here, I talk about how there was like a mass reanalysis of sauropod pelvises, and it showed that most of them have this really weird fusion of the vertebrae, where they curl upward. And that means that their back had to be tilted upwards,
Yeah.
like a slope for most derived sauropods.
Especially
There have also been
Tyrannosaurus.
studies that showed nothing holds its neck straight out like that.
And
It is every vertebrate has its neck upwards at an angle or straight up.
usually
Nothing like this.
it's above its heart. I don't quote me on this, but I mentioned Doc. There is something on there that a vertebrate, at least on land, cannot naturally hold its head above its heart due to something with how your blood and oxygen work.
Below.
Or below it, below your heart. Sorry, you can't naturally hold it due to something with that. Now, mind you, you can always. It's why when you go upside down, you cannot be upside down as a human for very long, or else all the blood rushes to your head, literally.
And even like animals like giraffes have special veins in their neck so they don't pop a blood vessel when they bend down to drink.
Correct. Yes.
Like long-necked animals have to specifically adapt to be able to hold their head down for short periods of time, let alone long periods.
And I guarantee sauropods, definitely the bigger ones like the brachiosaurids, probably had something similar, if not more insane than what giraffes do.
If they didn't just like lay down to drink, which part of me can kind of believe.
I could imagine they started kneeling. They did there's a lot of art of them kneeling on their front legs to literally just bend.
Tilt their body down.
Exactly. Yeah.
But yeah, just for a comparison, I get to illustrate kind of what I was talking about with the new posture. Here is the classic Diplodocus from Walking with Dinosaurs, and here is a much more updated reconstruction of Apatosaurus from a game called Beasts of Bermuda, which I really love, actually. Their rendition of Apatosaurus may be my favorite in all of media, actually.
Also, the other thing with the difference is I don't know if it's mentioned this, but we used to depict sauropods with very thin necks. Again, this is the shrink wrapping thing.
Yes.
But sauropods had very thin necks. We now think that sauropods had very thick, muscly, fatty necks.
Yeah. And keep in mind, there would have still been lots of air pockets in there just because of how they work, but the neck would have been thicker than we historically depict them.
Correct, which makes sense.
Yeah.
Especially
but anyway, enough preamble about sauropods as a whole.
Yay.
Let's meet the Robinsons, or Robinsauruses, rather. Let's actually get to meet some of these weird sauropods. And since we already kind of covered the base of the sauropod family tree, we're going to be skipping to the derived ones. Animals that are usually considered what's called eusauropods.
Yep.
These are animals that have kind of the more upright, sloping posture we mentioned earlier. They have really long necks. They have long tails. Your classic sauropods, basically, not the early things, though there are still plenty of weirdos to be found here. And yes, we're having a dino crisis in here, or at least we will be very soon.
Mm-hmm.
And this is roughly the order we're going to go in. I know there's a lot of big, complicated words in here. You don't have to memorize them. We'll walk you through them.
Very much.
With that said, we're going to start with stuff that's a little more familiar. Kind of.
The generic one.
Kind of. What you're looking at right now is arguably the first named sauropod, or at least the first one that's not just named off of teeth. This is Cetiosaurus, whose name translates to whale lizard, because when it was first discovered, the anatomist Sir Richard Owen recognized that it was a reptile, but he didn't recognize that it was a dinosaur. Though, ironically, a couple years later, he would go on to name the group Dinosauria. And it was so big that Owen thought it was too big to be terrestrial. Doesn't that sound familiar?
We do that a lot.
Well, we did that a lot.
We still do. Spinosaurus exists.
Okay, to be fair, Spinosaurus is an absolute freak compared to this family of absolute freaks.
Yeah, huh?
Now, Owen's initial description was mostly based on some vertebrae and fragments of limbs, but decades later, like in the 1870s, 1880s, we found more of Cetiosaurus. And we found enough that we were able to compare it to other large reptiles that were being discovered in North America, like Diplodocus and Brontosaurus. We finally figured out, oh, this is a British sauropod. And thanks to some other discoveries in the early 1900s, we have a decent idea of what Cetiosaurus and its relatives would have looked like, and it would have kind of looked something like this. A shorter neck than a lot of other sauropods, but still really big, about 50 or 60 feet long, and weighing 10 to 15 tons. And I'll just repeat that, 50 to 60 feet long, weighing 10 to 15 tons. That is absurd.
Made of air. But no, Stegosaurus is again, as you said, it's one of the earliest sauropods. It's very interesting because it shows that right after the Jurassic starts, sauropods get big really fast in evolutionary time.
This thing is estimated at about 166 to 170 million years old.
Which is very old.
Only 30 million years after the end of the Triassic.
Is
a mass extinction event.
Is it the same time we get the remnants of Dilophosaurus and Cryolophosaurus still?
I think those are closer to 180 to 190. But this is about the same time as Megalosaurus.
Oh yeah, but again, my point with that is about 10 million years earlier, these things were bipedal and maybe 2 or 3 tons.
The end of the Triassic, we see some that are closer to 8 or 9 tons.
But yeah,
these but still a lot smaller.
Big, fast, and thankfully we know a lot about this group. At least it's developmental. But yes, we also have someone who wants to ask questions. We get to Q&A portion. Fun.
Yes. If we will probably save Q&A to the end of the stream, but if you want, Alma, if you send in a super chat, we'll answer it right away. You can. I don't recall if you're monetized, Vandalia, but they can send it on my channel if they wish. Anyway, Cetiosaurus, the first sauropod. Pretty much, because the only other sauropod that could have that title is named off of teeth, and teeth taxa don't count.
Especially in dinosaurs, and especially in sauropods, where they literally all have the same teeth. All of them have the exact same teeth.
No. They're either pencils or spoons.
Oh, you're right. Yeah. You're right. It's one of 2 options. Hey, look! One of the options.
Yeah. And then, actually, Dom, if you want to count the cervical vertebrae while I talk about it,
sure. Let's go.
We'll see how much this abomination has. Mamenchisaurids, aka no such thing as too long. If you saw our previous stream on early sauropodomorphs, this may look a little familiar. Mamenchisaurids had the longest neck of any known animal. However, I should preface that by saying we may eventually find a titanosaur with a longer neck. It's just we don't have any with a complete set of neck vertebrae to compare it to. And we have no idea why they got so ridiculously long. This neck is, I think, a good 40 feet long or more. It is absurd.
Vertebrae. By the way, it's not even 20, it's 18.
So
18,
do you think
18 vertebrae.
In your own hypothesis or whatever, you think it was that this big long neck because of natural or sexual selection?
That's an excellent question, actually. Sauropods, so developing a long neck in nature, if you're on land, is very weird because you do it for 2 reasons. You either do it for hunting small things that can burrow. So technically, this is what snakes do. But snakes don't have long necks. Fun fact: snakes don't have long necks at all. They have very short necks. But like a lot of birds develop
They
long
turn
necks.
into a neck.
They turn into a neck, yes. But a lot of birds do this for either fishing or for like swans do it, for example. Swans do have long necks, for example. But when you have a neck that's 50 feet long, 60 feet long, there has to be another reason besides food, because you do not need a neck that long. Sexual display is an option, but I would hardly guess it must have been something else, right? Or both sexes were looking for long necks.
I mean, the thing is, a trait can be selected for in one sex and be carried over to the other.
Correct.
Just because your genetics have to be somewhat similar for you to mate.
But even still, this is an abomination. Also, by the way, the small estimate for this creature's length is 98 feet. That's the small estimate.
And that's total length. And I think over half of that is neck.
Yeah. Over half of that is neck. The series of dorsal vertebrae are 12 feet long each. That's not me. Well, that's all right. A series of dorsal vertebrae is 12 feet long.
Yeah, which it's actually not that long for a sauropod. That's kind of average. It's just the neck that's so absurdly long.
Correct. Its neck is 15 meters long. The animal is 30 meters long. It's half. It's awful.
And I mean, part of why I'm open to this just being runaway sexual selection is Mamenchisaurids die out, and no other sauropod gets it that long.
No,
like maybe it was just a thing for them.
Well, the other thing is, Mamenchisaurids are only in Asia. It might have been something specifically in Asia that they were very specialized in, too. Like a certain type of 100-foot tall tree for no reason.
But then what did the babies feed on? Or did they just feed on like smaller versions of those trees? Like I don't know.
That's true. You're right. It's just maybe the adults. Mind you, there were other weird things in Asia, like the weird thing that grows a beak and loses all of its teeth when it grows up.
Yeah.
But that's for a different day. It could be something like that. All Mamenchisaurs
actually, we already covered that since it's a Ceratosaur.
You're right. I hate it. But yeah, Mamenchisaurs are just weird. Runaway sexual selection could be other interesting. Then again, a lot of Asian sauropods do weird things. When we get to Shinosaurus and its family.
That was the last sauropod stream. We talked about Shinosaurus. We actually ended with Mamenchisaurids because I found a particularly pretty piece of art. This is still kind of the review phase.
I didn't know that. Okay, then I wasn't here for the last sauropod stream, but yes.
It was almost a year ago at this point, I think.
Oh, really?
I think it was over a year ago.
Yeah.
I think it was like June or July of last year.
It could be something weird. Runaway sexual selection isn't a bad idea, though. But yeah, Mamenchisaurids they're only Jurassic Asia. Only Jurassic Asia.
Yes.
It's very interesting.
Just kind of weird. They weren't around for long, but they definitely made their mark.
Yeah, they're the reason why we have access to Lemusaurus and Guanlong.
Yeah. Also, I'm just kind of noticing the way the overlay is, the artist credits are blocked out. If anyone in the chat likes any of the art they see, the presentation will be linked in the description. And if you want to look up any of these artists, please feel free.
Yes, art's good.
Yes, there's a lot of good art. Now then, let's get into a more normal sauropod.
I thought you were going to say reasonable, which is the wrong word.
No, familiar, and arguably one of the ambassadors of dinosaurs, at least American dinosaurs to the rest of the world.
Yep.
Because while Mamenchisaurids are characterized by those awfully long necks, there's another group that's characterized by awfully long tails. These would be the Diplodocutes.
Yes. Or Diplodocids, if you're correct.
Well, we'll get to Diplodokids next, but
Oh, you're right.
Diplodocoids is a larger group.
I hate. Yeah, that's still an awful. Diplodicoid is an awful word. It sounds like a nautilus, like some weird creature you found in the deep sea.
At least we're not going to
Okay.
the polycoid form to the polycoid morphs and all that.
Oh no, don't worry. We will get to that with the other family.
We'll get into Flagellocodon, Diplodocoid, or sorry, Flagellocodon, Diplodocid, Diplodocoid, Eusauropodon, Sauropodomorphs.
I was going to Titanosaur end, where it's like Macronarians, Titanosaur, Morph, Titanosaur. What was another one?
Yeah,
Another one?
Titanosaurs get bad.
Titanosaur
But
is
fortunately, Titanosaurus isn't valid anymore, so we can't have a Titanosaur Titanosaurid.
It should be. We looked into this.
Or Titanosaurine Titanosaur.
There might be, which is the Toba Titanosaur from Japan, because it still doesn't have a name yet. So we have looked into this.
Anyway, Diplodocoids. I mean, this is Diplodocus, Apatosaurus, Brontosaurus. When you think of a sauropod and it's not Brachiosaurus, it's probably one of these things. Famously, most of these are or at least, well, most Diplodokids are known from the American West, which is kind of interesting. Or Portugal.
Do we get Diplodokids at all in Asia?
I don't know off the top of my head.
I don't think we get any from Asia or Australia, because the ones from Portugal and Africa were probably came from North America. So Diplodokids probably started in North America.
Oh, if they're Americans, hopefully they're going to go to the next election.
They
left America. That's what they did.
Yeah, they escaped.
Anyway,
an interesting thing about Diplodocoids, or more specifically Diplodokids, is some of them have really good skin impressions and show that at least some of them would have had kind of a row of iguana-like spikes along the back of the body, which is shown in the Walking with Dinosaurs Diplodocus.
Yeah, it's very cool. The other awful thing that these things do is their nerves and their reception to movement.
Well, here, let me...
Yes, do this one.
There's the long boy.
The long... the long one is the main one. But yes.
Yes. Well, do you want to explain the nerve thing for long sauropods?
Yes. So, if you didn't know, you have pain receptors in your body. Like, let's say, for example, you hit yourself on your leg. You feel the pain immediately. Or about within like 0.0001 of a second, technically. Some animals have a bit slower pain receptors and much faster. For sauropods, even if they had the fastest pain nerve like retention of any animal on the planet, so which I think is birds or fish, right? It's one of the two.
I think so, yeah.
Yeah. It would take them 4 seconds to register the pain from the tip of their tail. If something could bite off their tail, the tip of the tail, and then 4 seconds later, it would feel the pain.
Just because of how long it takes the nerve impulse to travel the length of the body. It's absurd.
Yeah. Now, mind you, even if they had any feeling in their tail at all, because of some studies that they might have done some stuff to the ends of their tail. But
I remember growing up in the 80s and way back then in the olden days that they talked about having that these guys had 2 brains or something.
That was stegosaurs specifically.
Sauropods too.
Oh yes, but I think it was more pronounced in stegosaurids for some reason.
But no, they did not have 2 brains. We do not know of any vertebrate with 2 brains. What they had is actually something that humans have, and actually most vertebrates do, which is over the hips, or more like within the hips, there's an enlargement in the spinal cord, and that enlargement leaves an extra large space in the hip. And the longer your backside, or the bigger your backside is, the bigger that space is. So for things like sauropods, they had an extra large bundle of nerve tissue there. And it's not a brain. It's more so
It's like a
it's like a
conjunction neuron.
reactive center, kind of. Like it reacts to stimuli sooner than if the signal went all the way to the brain, but it doesn't fully control it. It's kind of like a relay system.
Yes, a relay
It
system.
helps them walk correctly and move their muscles in the rear half of their body correctly.
Correct, because it would still take a while. Like, it would take them like 2 or 3 seconds for their brain to tell them to whip the tail. But probably around a second or two for if they wanted to move the tail properly. That nerve center allows them to do it instantly.
Well, or at least like they think about moving, and by the time they start moving their front legs, the signal has reached their back legs that they're going to start moving.
Correct. Yes, it allows them to move properly. It's also what allows you. Again, you have the same things in all the things. It's why when you move certain parts of your body, other parts move.
Yeah, or like Dom said, if you bang your knee on something, you actually react sooner than you register the pain.
Correct.
Because it hits that reactive bundle in your hip and then goes back out to your leg to move it out of the way.
Correct. Like cuts, for example. You sometimes might get cut on your leg, and then a second or two later, you're like, "Oh, ow!"
Well, I'm saying like your leg will pull away.
Oh,
But it's especially good with burns.
Oh yeah, burns. It's actually a very good with burns.
Because your arms have a similar reactive center in your spine.
Yeah.
Like if you touch something hot and you get burned, your hand will pull away before you register it.
You'll immediately pull away, and then it will start to hurt.
Yeah.
Yeah. It's a safety thing.
Yeah. Anyway, while diplodocids were not the largest animals in the world by mass, in fact, they were actually really light even for sauropods.
Yeah.
Many of them,
mostly tail,
or at least some of them, may have been the longest animals ever to live. There are 2, I believe, currently valid species of Diplodocus. One of them, named Diplodocus halorum, is estimated at 30 to 40 meters long, and that's based on some fairly good fossils.
That's like 140 feet long, by the way. That is far longer than the blue whale. That's actually about this. That's the same length as my street, or about this half the length of my street, which is disgustingly long.
It's massive. But keep in mind, almost half of that is like this whip-like tail.
Yes.
And we don't know why they had such a long tail. Like with mamenchisaurs, maybe diplodocid females had a thing for long tails. They wouldn't be the first reptiles to do that.
Yes. There's also some evidence that, so doctors say whip-like. There was a study that shows that these dinosaurs couldn't make the whip crack with their tail. They'd break all the vertebrae in their spine. Yes. There is evidence that some of them probably had, like, either just like really hardened the end of their tails. I believe some of their vertebrae, what's the word? It's not ossified.
Ossified?
Ossified, thank you. The end of the vertebrae is really ossified, or just like that, where even if they couldn't crack it like a whip, getting hit by this thing would hurt anything. It would cut you because of how thin and how fast it moves.
I mean, it's like a telephone and a half, or like a telephone pole and a half foot long, even with the shorter one.
Correct.
Like, that's going to hurt if it hits you.
And it might even cut you with, like, because if you get hit by something going pretty fast and it's pretty thin, which the end of the tails probably were a bit thin, that will cut and it will sting like hell.
Yeah. So even if they couldn't whip, probably be good for defense.
Especially because it's so long.
And
the other defense, which is better.
Yeah. But with that said, as I mentioned before, diplodocids were weirdly light for their size, even for sauropods. Some of the largest ones top out at around 20 tons, which for a sauropod is not that big.
That's really light.
Like, that is the average weight for a titanosaur, less than 2/3 the length of a diplodocus. And some strange, robust diplodocids, such as Apatosaurus and Brontosaurus, had weirdly reinforced neck vertebrae too for sauropods, which has led to a hypothesis called the Bronto Smash hypothesis.
It's the best name for anything.
Suggesting they may have used their necks for defense as much as legs or tails.
We even have some,
which
we have some
kind of crazy
evidence. I believe it's in Brontosaurus specifically of the ends of their vertebrae are really bulbous, and they could have supported either like large osteoderms or hell even spikes on the bottoms of their neck.
I think it's been suggested, but I don't know if we have anything solid to back that up.
Solid, yes, but they could have, is what I'm saying, and it wouldn't be out of the realm of hypothesis.
Also, someone is bringing up, Dom, your audio is kind of choppy and staticky.
Is it on? Can you hear that as well?
I hear it too, yeah.
Okay. That's weird. Give me 2 seconds. Oh, that's why.
Weirdly
2 seconds.
All right.
Back to these messages. If we had messages.
Yeah. Oh, I brought up Beasts of Bermuda before. I'm pretty sure that this painting by Mark Whitten inspired one of the skins for Apatosaurus in that game, which I think is kind of cool.
Have you live streamed that game?
I mean, maybe someday. My computer is not that powerful, but it might be kind of fun. It's not super realistic, and the game definitely takes some creative liberties with some creatures. I mean, for example, any dinosaur can be bioluminescent, which probably they couldn't do. But it's a fun game. And one thing I actually really love is they had two models, or they have two models for Apatosaurus. And one of them is Apatosaurus, and it's bigger and heavier and slower. And the other is Brontosaurus, and it's smaller, and it can smack things with its neck. Just kind of fun.
Is that better at all?
Dom. Yeah, you're a little echoey, but the scratchiness is gone.
Yeah,
that's good. That's good. Yeah. Okay. Perfect.
Away from the familiar diplodocids.
Awful thing!
Surprise Rabakisaur jump scare.
So, I'm going to steal...
In this group of exceptionally long, whip-tailed sauropods, there were some weirdos who were not that at all, but still belonged to that group.
Awful things.
Dom, you wanted the weirdos. Do you want to talk about this lawnmower?
I'm going to talk about the lawnmower, and then eventually the living barbed wire that is the next one. So diplodocids, for some reason, do really fucking weird things. At least their relatives do. So either you get the normal ones, like Apatosaurus, Apatosaurus, Diplodocus, Brontosaurus, blah, blah, blah. And then for some reason, they decide to get really short necks, and this one became a lawnmower. We don't know why. Fun fact about Nigersaurus too, because this is Nigersaurus. Its head, its base position for its head is 90 degrees straight down.
I think we thought that originally, but now it's thought to have a more normal neck posture.
No, it's the opposite.
Oh, it got worse?
Yeah, no. We used to thought it was more normal. The position for the head, from what I understand, I can double check this, is about 45 to 60 degrees pointing straight down.
Just walking around like this.
Yes. It's awful. Awful animal. It's a living lawnmower, as you can see. Its head does a really wide thing. It also has a really short neck.
Yes.
And I believe there's a Rabashysaurid that does the short neck thing even worse. It is called Brachycephalopan. That's
it's not a Rabakisaurid.
It's not? I thought it was. What is it?
No. We'll get to it in a minute.
Oh God. Yeah. But these type of Rabachisaurids, at least the Nigersaurs, appear to only in Africa after the split. But there are some Rabachisaurids from America. One very important one by the name of Marapunisaurus, which initially was only known from this drawing. Cope said he found a vertebrae that was about 3-4 meters tall, and the vertebrae then disappeared. We knew it did
2.5 to 3 meters, but yeah.
2.5, 3 meters. We knew it existed. We knew Cope didn't make it up, but we only had a drawing. Apparently, recently, we've either refound the vertebrae or found extra evidence to support that Marapunisaurus that exists. And if it did, it was probably one of the largest dinosaurs to ever exist. It was probably around 60 to 70 feet long as a Rabachysaurid, which is gigantic.
This thing, but as long as Diplodocus.
Exactly.
Massive.
It was also probably really heavy, because I think Rabachysaurids are slightly heavier average.
Or at least they're more solidly built than other Diplodocus, yeah.
Yes. This is also when Doc said we might get to, if we ever had a semi-aquatic sauropod, it would be a Rabachysaurid, probably.
Probably.
Yeah.
But yeah, like Dom mentioned, I don't know if it was like the original and was just found in storage or what, but we have 3 or 4 vertebrae from this giant, whatever it was, and it's probably a Rabachysaurid. If it is a more typical Diplodocid, which is not currently supported, this thing would be like 160 to 200 feet long.
This would be the biggest animal that have ever lived, full stop, if it was a proper Diplodocid. This animal literally would have been incomprehensible by humans. That's how big it would be.
Half to 2/3 the length of a football field.
Correct. And it
Counting
probably
the end
40 to
zones.
50 tons as a Diplodocid.
I think it's over 100 tons because square cube law.
Oh yeah, which is gigantic. I think so. The Rabachysaurid is like 60 tons if it's a Rabachysaurid.
Yeah. And that's the smaller estimate.
This isn't the only. A lot of. I believe that's correct. But we found a lot of parts of sauropods. I believe there's 2 or 3 that are giant sauropods known from very little evidence. We'll talk about the other one later when we get to the real giants. But this was the first one.
Yes. And Caden, this is not Diplodocus halorum. We actually have a lot of Diplodocus halorum.
We do.
We have most of the rear half of the skeleton, I think.
I believe this was attributed to Diplodocus halorum. Oh no, it's attributed to something other name.
No, it was called Amphicelius was what it was called.
Amphicelius is such a cool name. Why didn't it? It should have kept the name Amphicelius, but it was reclassified.
My guess is we found the new giant vertebrae. They were called Marapunisaurus, and since they had a proper description, the name was shifted.
That'd be my.
It's just a guess, though.
I like Amphicelius a lot more than Marapunisaurus. Amphicelius feels giant.
Yeah, kinda.
It really does feel giant.
But yeah, here's the weird thing, though. There's kind of a bell curve with dinosaurs. Once you get up to a certain size, it's easier for you to preserve. But as you get bigger and bigger and bigger, the chances of any part of you besides one bone getting preserved exponentially decreases just because of how massive you are.
Yeah, for some reason, really big sauropods on death immediately implode, especially their heads.
They explode and scatter themselves across Patagonia.
You're right. It's a really weird thing that just happens with sauropods. We don't know why they just exploded randomly. Obviously, this is a joke, but it's very interesting that sauropods, once you get to a certain size, we find like one giant vertebrae or one giant leg, and then nothing else. Or Patagotitan, most of the animal.
So, how much percentage?
Dirdonus is most of the animal. Sorry.
So, how much percentage have we found of the sauropod?
Of this one?
Of any one, complete one.
Sorry, of anyone, what, Vandalia?
And what's the least complete sauropod we found?
We found some that are almost, or at least mostly complete.
I
We'll
believe
actually have a photo of one later on in this presentation that I think is like 80 to 90% complete or more.
most of the ones
Um,
that are complete are from South America or North America, though.
yes. Or Asia sometimes.
Eh,
Uh,
yeah,
but we do have mostly complete sauropods at the very least. It's
which is
just
cool.
the really big ones are fragments.
They explode.
All of them are fragments except for Diplodocus halorum, which, like I said, is like half of the skeleton, and Dreadnoughtus, which is like 3/4 of the skeleton. I think it's only
We have a
missing the head
lot.
and neck.
We have a lot of Dreadnoughtus. We have an exceptional amount of Dreadnoughtus.
Yeah, which is weird.
Now, speaking of weird things, let's talk about, for some reason, a dinosaur that did this.
Just have fun, Dom. Go
So,
ahead.
Yeah, Dicraeosaurs are dumb. Dicraeosaurs appear to be they're only South American, right? Or I think there's one in North America. There's one in North America.
There's one or two in North America. The one I know of is Soasea.
Zoasia, yes. As long is it is a Piscicaudia also one, or is that something else?
I think it's a Titanosaur. Let me double check, but I think it's a Titanosaur.
But yes, Zoasia. And I don't Zoasia is I don't think that weird compared to its relatives, but Dicraeosaurs, one thing in common. They do stupid things with their necks. So one, they shorten them, and two, for some reason, in at least two of them, they decide to grow dumb fucking spikes out of them.
Well, sails.
I think it's Sailed Amargasaurus. I think Dicraeosaurus might actually be spikes.
I don't think Dicraeosaurus has the weird neck spines.
Oh no, it's
Or at
Bahatasaurus.
least it's not known.
It's Bahatasaurus.
Well,
Excuse
no,
me.
Bahatasaurus is also sails.
Is it also a sail? I thought Bahatasaurus was.
Or at least it's likely to be also sails.
Okay.
So
Regardless.
these are like protofeathers since they're on the sauropod side.
No, they're worse.
No, these are spikes. These are vertebra extensions.
These are awful. The best example of this is a Margosaurus. If you ever seen a Margosaurus, it has these very long, always, what's the word? Not bifurcate. Is it bifurcating?
It is bifurcated because a lot of Diplodocids do that. Here we go. This is Amargasaurus kazawi with apparently an anime girl for scale.
I know who that is. Yeah, I don't know why. A lot of sauropods weirdly have like VTubers for their scale. I don't know why. But yes, you see the bifurcated things, which is double, except for the first one, which is always singular. So
I'll get a picture from the front.
They always go out like this, and they go for pretty long. Initially, they were thought to be sails. Then, in the mid 2000s, we actually thought they might have been spikes due to certain things. And then, very recently-ish, it was shown that because of the tension on the end of on the Amargasauruses, it means they were attached via tendons. So we know at least they were in at least the middle part were in some sort of like flesh sail thing.
Yes, and this is Amargasaurus's vertebra. So in most animals, there would just be one single spike here in the middle. This is from the front or back. Diplodocids do this weird thing where they split their neck vertebrae, and they get two spines like this, which is a really rare adaptation you usually only see in things with really heavy heads, which these things don't have.
They just make them. They just make sails. This has to be sexual display. This has to be a sexual thing or something of that. It's not. They're not. These are on very small animals, on a lot smaller sauropods, so it's probably not for anything to do with like temperature regulation, because there are bigger sauropods that don't have these, and things like Bahatasaurus. If you get a picture of Bahatasaurus, they for some reason instead of
this is Bahatasaurus.
Well, yeah, but like of the like what the skeletal version, but this also works. But Amargasaurus does have them point in this laid back. Bahadasaurus curls them over their head for no reason in particular, which looks insane. I think Dicraeosaurus does something a bit similar. I know Dicraeosaurus does have them, but Dicraeosaurus is weird as well. And then
Oh, hey, look, Bahadasaurus with an anime girl.
yeah, they're all by the same person, by the way. They're all from the same paper. Look, they're all from the same 2022 paper.
What do you mean by that?
Or they're all from the Creative Commons Gunnar Blevins 2022. All of them with the anime girl.
I don't think this is from a paper. I think like this guy's just an artist.
Oh, they're all from the same person, all of them, and they're really good. But also, it's Pronospinax is a great scientific name for this thing.
But was that like pronounced spine or something?
Yes. Which, yeah. But you see they point in front of it. I think there's evidence of, in some of them literally going over their head. And then, for some reason, unlike all of its relatives, there's Brachytrachelopan, which is the worst one, because for some reason, it's a hadrosaur. For some ungodly reason, it's a sauropod that becomes a hadrosaur. It shrinks its neck so much. There's a picture of it right there. It looks awful.
It just looks incorrect, but that's just what the skeleton is.
Yeah, Brachytrachelopan is awful. Let me see if there's any more weird things, because this is an awful family. I
don't want to spend too much longer on this. There is other stuff I have to do tonight, but yeah, they're dumb and they're weird. And Diplodocids are when sauropods get freaky.
No,
in comparison,
does.
Titanosaurs are much more normal, whatever that means for a sauropod.
You know what Dicraeosaurus does? Dicraeosaurus just has little fucking ridges of bumps down its neck.
Pretty much, yeah.
It's awful.
Yeah.
There's only 6 of them. I didn't even know that. We talked about all of them, but 2. Which is Dystronophoneus, which you don't have the neck for, so we have no idea. And then the other Wyoming one, which we also don't have the neck for, it's just legs.
Oh yeah, Sawasea. No, we have some of the neck for Sawasea.
No, I wasn't talking about Sawasea. I was talking about Dicycloposaurus or Disloclosaurus.
Oh yeah.
Because Sawasea is very basal. Mind you, every one of these that we've found the neck, besides Sawasea, the neck has been awful and stupid. So, I don't know why they do this. They definitely fed very differently. They are unique though. The Dicraeosaurs are unique, where, unlike other sauropods, which have an uneven number of teeth on their top and lower jaw, Dicraeosaurs have an even number of teeth in their top and lower jaw.
They're weird. They're very, very weird.
This is, I don't know why these things do this. They're known from, I forgot they're known from Africa too. There's one in Africa, apparently.
Yeah. Africa, South America, and North America.
Yeah.
None yet from Portugal, but it would not be surprising to find them.
It would not be surprising from and Amargasaurus is the last of its kind in the Cretaceous. We might find more, but Amargasaurus might generally be the last one because of how weird it is, and it's very similar to its other weirdos. You tend to get the most pronounced of the last of a species tends to be the most pronounced, usually in nature.
Sometimes.
Yes. So the Dicraeosaurs are weird. They're kind of, again, these could be anything for what they do. Brachytrachelopan looks like it couldn't eat food because of how high it's off the ground because it's a sauropod, but its neck is stupidly short. It's not the only one, by the way.
Really?
There's another one that does a stupidly short neck as well, called like Ling Ching or something, like Ling Shuesaurus or something like that.
They're bad animals.
Bad, very bad. I love them to death. Bad.
Yes, and I will say before we move on, hello, Jody Wolf. Hello. I know you. Gonna go ahead and
Continue to better ones, a lot better. Ones.
yes. Now from here on, we are swapping from the Diplodocids, which unfortunately do die out in the early Cretaceous. No Diplodocid that we know of makes it to the end.
The last one's a Margosaurus.
The only group of sauropods that makes it to the end of the Cretaceous are the macronarians, or the big nose sauropods. And they're called that for good reason. See, one of the most common and well-studied sauropods of this group is Camarasaurus, meaning chambered lizard. Weirdly enough, not for its skull, it's named after its vertebrae because it was a Bone Wars discovery. But the head has this massive vaulted ceiling with a gigantic nose. And we don't know why. I don't think the brain suggests it's particularly well suited to smell. It just had a big nose. It's been proposed maybe to help with temperature, maybe for making noises, maybe for showing off, maybe they were brightly colored. We don't know.
Maybe for a nose balloon, like in a certain documentary of one of the episodes I like.
Yeah, no idea. But whatever the reason, it got passed on. And macronarians, like we said, are the only sauropods to make it to the end of the Cretaceous.
I think at one point it was thought that it was to literally help it breathe because they have such tall necks.
But explain the Menkysaurus.
Exactly. Which the immediate thing is that Menkysaurus.
Yeah. And speaking of mostly complete skeletons, this is the skeleton of a mostly complete juvenile Camarasaurus.
We have baby Camarasaurus. Yeah, we have baby Camarasaurus too.
Yeah.
We tend not to get
we also have a possibly baby Brachiosaurus that was actually found pretty near where I'm living right now.
Yeah, we do. We don't have a lot of baby sauropods. It's sad.
No. Turns out things probably like to eat them.
Yeah, I mentioned earlier that sauropods are probably keystone species, probably because like a salmon run, the yearly hatching of baby sauropods, or maybe even like 2 or 3 yearly hatching of baby sauropods, was probably an event for every predator within miles of that nest site.
Yes. Which I've only seen properly captured in one documentary, that being Dinosaur Planet from the early 2000s.
Yeah, it's the only one.
Which just has a sea of Saltosaurus babies getting devoured by every predator in sight.
By crocodiles, by ankylosaurs, by an alvarezsaur, by dromaeosaur, probably more things.
Not dromaeosaur, but yeah, just everything that ate meat in the area.
I would having a guess that maybe even some sauropod, not sort of some like hadrosaurs, not maybe hadrosaurs, but like some like herbivores snacked on a baby sauropod, like snacked on a baby bird, because it's a bunch of protein.
Yeah, and they can't run away from you.
No, they're a ball of fat that can't move.
They're walking chicken nuggets.
They are. That is how they're described. Yeah, they're walking dino nuggies. They're living dino.
But apparently they were successful.
Very. If you have 1,000 babies, at least 2 will survive.
Yeah. And with the macronarians, the group that gets a lot of attention, and for good reason, are the titanosaurs. And, I mean, it's in the name. These are at least as far as we know, the largest sauropods, the largest things to ever live on land. They're so big that this one's head's actually getting cut off because of the overlay.
They're so big. They have some of the coolest names in dinosaurs in history, and in my opinion, their new namesake which is Dreadnoughtus, kind of encompasses what a titanosaur is. When we get to the big ones,
Yes.
I'll explain why. But
Titanosaurs are often named for one of two things: weirdly specific tiny anatomical details, or they're named after gods.
or where they're from. We have a lot that where they're
or where they're from.
Yes, we have a lot of those. Patagonia and Argentinosaurus, Diamantosaurus.
Which I mean, I'm sorry, if I find a new Titanosaur, I'm not naming it after a country.
No, you name it a god. These were gods.
Yes.
These exist,
and
religions would be worshipping them.
Yes. These things would walk down a city street and look into a 6 or 7 story building easily.
Yes, there's a Titanosaur named Kaiju Titan Maui, which is a great name. The giant monster.
Yes. And we talked before about how diplodocids were ridiculously long. Titanosaurs got ridiculously tall and massive.
And
keep in mind, Amenchosaurids currently hold the record for the longest confirmed neck length. Titanosaurs are fragmentary, but they probably give them a run for their money.
There's one,
especially the biggest ones.
There's a fragmentary one that's proposed to be bigger.
There are several fragmentary ones.
Yes.
And keep in mind, most sauropods were pretty tall. Like a short sauropod is 20 or 30 feet long, 20 or 30 feet tall. That's a 2 or 3 story building.
These things were huge.
Titanosaurs were probably the tallest animals to live on land, and the one currently closest to holding that record, at least the most complete one, is this one here, Sauroposeidon, which is estimated to be at minimum 50 feet tall, but possibly up to 65 feet in height, which is insane.
Based on gods, you heard Poseidon, but it's not named for the ocean variety. The reason why this thing's named Poseidon is due to Poseidon's other pantheons. That's another word, but this is the
other attribute.
Other attributed. This is the earthquake god lizard.
This is the lizard of the earthquake god.
Yes.
And I forget what its species name means.
Its species name is pretty good too, from what I remember.
I know it's Proteles. I forget what the species name means, but just the lizard of the earthquake god is pretty
good,
pretty cool, and pretty accurate.
Yeah.
And I wanted to include Sauroposeidon in particular, because I'm pretty certain I've found at least one.
Yep.
For anyone who doesn't know, I do a lot of field work in the Cloverleaf Formation, which is known to have Sauroposeidon in it. And I have found several exceptionally large titanosaurs.
Yes, he has. I've seen pictures.
This is the most likely one that I've found.
Yep. It's also the last surviving North American sauropod, from what we know.
That we know of. It's one of the last ones, yeah.
Yep.
Which we kind of mentioned before, but for some reason, sauropods disappear from North America for about 100 to 66 million years.
And the one from 66
And even at the end, they only appear in Texas and New Mexico.
And we know where they're probably coming from.
Yeah, what's south of North America?
Yep.
But Sauroposeidon is also worthy of mention for a specific trackway from Texas, which not the same trackway we mentioned before. Those might be Sauroposeidon as well. Different trackway that involve another dinosaur.
Yes. This is interpreted as probably an Acrocanthosaurus hunting probably a Sauroposeidon. Now, these animals could have actually walked from like days or weeks apart from each other, but it's cool to have fun with it.
But I would have to see if there's an actual study in analyzing the trackway. But I do know there is a point where the theropod's tracks just disappear for a couple steps. And during that time, the sauropod trackway appears to lurch
Yes,
toward the theropod,
yes,
suggesting
that it bit and held on somehow for just a couple steps. Like bit and was dragged for like a few feet.
which, for most theropods I would question it, but for an allosauride,
No,
they're kind of crazy.
No, they did that. Especially because if we do Carcharodontosaurids and allosaurids in general, probably were specialized or specializing in hunting sauropods.
Yes. And Acrocanthosaurus in particular, it's in this weird middle zone because later Carcharodontosaurids tend to have really tiny arms. Acrocanthosaurus doesn't.
Really
it has
cool.
these giant meat hook arms like Allosaurus does, but it's the size of a T-Rex.
But some Titanosaurs...
And it's built like a bodybuilder.
It was. Some Titanosaurs were not that big. I believe that's the next slide. Please tell me I did it right.
Yep.
Yay, I did it. All right, you go small because I want to take the big one.
I thought you wanted the small one.
I want the big one. I want Dread.
Well, there's a few big ones. Yeah. But yeah, Titanosaurs, despite their name, not all of them were massive. There were some small Titanosaurs, because Titanosaurs are found on literally every continent. They're only found in the southern part of North America towards the end of the Cretaceous, but otherwise they are known from every single continent.
Everywhere.
Including areas that appear to be island habitats. Such is the case for this little guy called Magyarosaurus. Magyarosaurus is from Hateg Island in Romania. And it is, or at least it appears to be, a dwarf titanosaur. Now keep in mind that means it's about the size of a hippo and not a pygmy one.
Yep.
But compared to the average sauropod, that's tiny. Absolutely tiny. And also, just as a little bit of nightmare fuel, its main predator may have been a giant pterosaur, at least when it was young.
Horrifying animals. That island was hell. Literally hell.
Because weird phenomenon with islands. Big animals tend to get tiny. Tiny animals tend to get huge. See the dodo, which used to be a pigeon. Well, and then went extinct.
Also, animals that tend to be able to fly tend to get very big. See Haast's eagle, or Hatzegopteryx.
Or Hatzegopteryx.
Yeah. Yes, there are other ones like Ampelosaurus and Saltosaurus. Or also,
Ampelosaurus isn't a dwarf, and Saltosaurus is small for a titanosaur, but it's not a dwarf. It's just kind of small. Ampelosaurus is about average, I think. I think it's like 50 or 60 feet long.
I thought it was 40. But yeah, there are smaller titanosaurs. They weren't just the big ones. They were all sizes. It does appear titanosaurs literally took every sauropod niche during the entirety of the Cretaceous.
Every herbivorous niche, yeah. And I just checked. Ampelosaurus is about 50 feet long.
That's too big.
I mean, it's what I'm seeing online. Could be wrong.
I just disagree with its existence, personally.
Compared to the other things, you disagree with that?
I'm sorry. Medium-sized titanosaur just feels wrong to me.
You seem to be very bigoted against sauropods today.
The reason why for this, and it's a thing that happens when I want to be if I was ever to properly go into paleontology and write papers, I have two wants of study I want, which are either sauropods or pliosaurs, or plesiosaurs in general. And the thing happens when you're in paleontology, you tend to despise the things you work on because you
It's a love-hate relationship. It's a love-hate relationship.
if you talk to any paleontologist and ask, what are you currently working on the most? They'll answer you. And then if you ask them, what do you like doing that? They'll answer will be, yes, but I hate them immensely.
It just kind of happens.
Yeah.
But Dom, I think you wanted to talk about something big. Is that correct?
The giants, yes. I mentioned that Dreadnoughtus, its name accompanies what it means to be a titanosaur, which Dreadnoughtus means fears nothing. That's because these things were so big. As an adult, they had no predators. They were literally titans. Patagotitan, Argentinosaurus, which things we have a lot of evidence, have a lot of fossils for, could have been 100 to 150 feet, if not 150, 115, 150 feet. These things are giants. Alamosaurus, for example, as well, which we have a lot for, was 85, 90 feet long. These things also probably weighed 60 tons, 70 tons. These were monsters.
That's small
Genuine,
for some estimates.
I'm aware. Genuine monsters. And these aren't even the big ones. These are the ones that we know of. There's one titanosaur that I know the name of that's very fragmentary, named Bruhethcaosaurus, which, if it's fragmentary and if its estimates are real, could have been upwards of 180 feet long and 90 to 100 tons, which would make it actively bigger than a blue whale, which is
Kind of insane.
disgustingly massive. On these things, we don't know why these things got so big. At least with like the brachiosaurs, there's only one or two of them that get that big. The macronarians, the late Cretaceous titanosaurs, all of them are gigantic for apparently no reason.
Well, Saltosaurus lived on the mainland and it was actually really small.
Saltosaurus is weird.
You're either below average for a sauropod or you are the biggest thing that has ever lived.
Correct. And again, it's starting to get to a point where we're getting so many sauropods that things like Argentinosaurus are starting to be seen as average for titanosaurs. When we discovered Argentinosaurus in the 90s, the scientists were stunned how big this thing was. There's a picture of a paleontologist laying next to its femur? Is it its femur?
Yes.
And it's half the size of the femur.
The femur is about 8 feet long. I have Patagotitan's femur on the next page.
Exactly. Yeah. These are giants. And then we have proper estimates for these things too. The big ones. Have you ever seen the Patagotitan? And I believe it's in the A&H, right? Puertosaurus.
So it's in a few. No, it is Patagotitan. It's casts of it have been sent to several places. There's one at the A&H and there's another at the Field Museum.
Yes.
And I think there's a third somewhere else. Maybe London?
I think it's in London, yeah. These things are huge. Genuinely giants. And I will remind you, think back to the babies. The babies of these titanosaurs are not much bigger than the babies of other sauropods. They make maybe this big.
These are the babies that put on 4 tons of weight in their first 2 years of life.
These things, and the other thing is that normally with like large animals, there's not many in the environment. There'd be a lot of at least mid-size of these sauropods everywhere. So a lot of 50 to 70 foot long animals. The giants, like, if you ever have seen what proper gigantism does to an animal, it insanely big. One of these animals' gigantism would easily be 100 tons, easily be 140, 150 feet long. Never mind the size estimates for Bruhethcaosaurus and other fragmentary ones.
Yeah, they get absolutely absurdly massive.
Yeah.
And well, it is hard to get a grasp on how long they were because, as we said before, gigantic sauropods tend to be fragmentary. But we do have a decent way to estimate their mass.
Yes.
And that's because one of the most commonly preserved bones for these giants
Femur.
is the femur, which also happens to be one of the major weight bearing bones in the body. And there is a method you can use using the circumference of a femur to estimate the mass of an animal, or at least its hypothetical maximum mass. And this method has been tried on a ton of different animals, and the equations are a little different for bipeds versus quadrupeds, but it's
It tends to be
very
pretty accurate.
consistent. This is
Yeah.
very good at predicting the right answer in modern
I
animals.
think for sauropods, it's a bit weird because how airy sauropods are, but even then, it's pretty good.
Yeah. And this estimate has given a weight of like 100 tons for some sauropods, like Argentinosaurus, Patagotitan, Puertosaurus was brought up earlier.
Dreadnoughtus, Burhethchaosaurus, Diamantosaurus.
Well, so Dreadnoughtus is probably the most complete of these supermassive ones, and it's nowhere near the biggest. Its
Not
maximum weight estimate, I think, is like 55 tons, and it's not the biggest.
correct. I think, yeah. But things like Diamantosaurus, there's also a Titanosaur that's excessively big from Japan, which we have a lot of, called the Toba Titan. We do a bit of research into this, because it's in a game. But these things were genuinely kaiju. I think someone said kaiju of the dinosaur worlds. These were kaiju. I cannot hammer this in enough that until you see a skeleton of these things in person, you do not realize how big the scale of these things are.
Yes, and I do have something else to kind of show off that scale on the last slide.
Yes.
Oh, here.
Oh, there's one more thing with
Yeah.
the scale of these
Well,
things.
go ahead.
Sorry, you mentioned this earlier. With titanosaurs, we tend to not use humans for scale. We use elephants or giraffes. That's just how big they are. Are humans insignificant?
But on the opposite end of the spectrum, is this picture. So that's me in the picture with one of my little sisters. We went to the Field Museum for my 18th birthday. And this is her next to the foot of Patagotitan.
It's gigantic animals. Gigantic.
Kinda is. And to the people who are still here listening, just wanted to say thank you. Hope you enjoyed this little presentation on sauropod evolution and sauropod diversity.
So
For
what
Dom and
species
me
of
both, sauropods are some of our favorite dinosaurs, and they're really fascinating animals.
what species of sauropod are you holding there?
That is a Babyosaurus.
And Caden says, what evolutionary pressures to push these organisms to grow so large? There's a big one, which would probably be in these cases. Size is sexual. Is sexual.
Sexual display, like sexual
easily
selection.
imagine, in animals like this, the bigger you are, the healthier you are, and the females probably mate with the biggest ones. So eventually, if you just keep doing that, you get giants.
It's kind of like not sea lions. What are the huge seals that weigh like 2 or 3 tons?
Elephant seals do it. Yeah, elephant seals are gigantic.
Yeah. Kind of like
Yeah,
elephant seals.
I had a question I've been wanting to ask for a while. It appeared on the diplocoid.
Yes.
Yeah, I can go back there.
What's the deal with the Apatosaurus, Brontosaurus myth legend mixed up thing that I've
Okay. So, Doc and I can kind of split this, but initially, Brontosaurus and Apatosaurus were named different things. That's because they're named during the Bone Wars, blah, blah, blah. Then in the 80s or 90s, Brontosaurus was shelved because Apatosaurus came first, but because Brontosaurus is a better name than Apatosaurus, it just kind of stuck around and became kind of just a term for general sauropod. But then in the mid 2000s, Doc.
Well, I, going back a little bit,
Yeah, sorry.
like Dom said, Apatosaurus and Brontosaurus were Bone Wars discoveries. This was when Cope and Marsh were fighting over who could name the most extinct animals. Marsh named Apatosaurus first, and then he later on named two other very similar sauropods called Brontosaurus and Atlantosaurus. I think Atlantosaurus might be referencing Atlantis, but I'm not sure.
Probably.
Later on, to be honest, Cope and Marsh made a massive mess of dinosaur taxonomy. Because again, they wanted to name the most species.
And faked it sometimes.
Sometimes they faked it. Sometimes they picked super minor differences and named a whole new dinosaur off of it. Sometimes both. Sometimes they blew up each other's fossils.
Or their own fossils. The other couldn't find them.
To be honest, we are still sorting through the mess they left behind.
Yep.
Like Dom said, later on in the 20th century, paleontologists took a look at Brontosaurus, Apatosaurus, and Atlantosaurus and realized, hey, these animals are very, very similar. They're probably just the same thing. So Atlantosaurus and Brontosaurus were sunk into Apatosaurus. This is a process in paleontology called synonymization. Like, think of how we have synonymous words in English. It's the same thing, but for dinosaur names.
Yep.
And generally, the name that came first takes priority. Since Apatosaurus was published first, they became Apatosaurus. In the 2010s, there was a very in-depth study carried out on Apatosaurus, just generally. And the researchers found that there were two fairly distinct versions of Apatosaurus, in air quotes. And one of these variations was the Brontosaurus holotype. So the thing that Brontosaurus was attached to. So they split Apatosaurus and Brontosaurus again, making Brontosaurus valid again. I think Atlantosaurus is still Apatosaurus.
It appears Atlantosaurus is just Apatosaurus, and Cope might have named Apatosaurus twice.
Well, they were Marsh. All three were Marsh.
Marsh, yeah.
But really, the distinction is kind of blurry when it comes to dinosaur genera. Like Apatosaurus and Brontosaurus, those are genera, they're not species. They're kind of blurry. Whatever these animals are, they are the closest known relatives of each other, outside of their individual species.
Again,
they're the closest things to each other. So it's not surprising that earlier paleontologists grouped them together. And honestly, depending on how things shake out in the future, maybe they'll be lumped together again. They're that similar. That's just kind of how it goes when you're working with extinct animals. You can't run a DNA test. You can't try and make them mate. None of that. You just have to go with what the bones tell you.
There is something that's been happening in the later. There's two things that have been happening in the early 2000s and later 2000s. The early 2000s have an issue of some synonymizing things that don't need to be synonymized. That especially in the North American Hell Creek things, there are some things that do need to be synonymized. Put Pachycephalosaurus.
We're not having that discussion, Nedry. Not again. We already did ornithischians.
I'm aware, but there was a thing that, like, for example, someone thought that all of Compsognathidae doesn't exist and all of them are babies.
Well, that was a 2024 thing.
I'm aware, but it followed the same trope. But it does appear that we're breaking out of that phase, and a lot of people are re-examining some of these synonymizations and realizing, wait, we don't need to do that anymore. Also, a lot of younger paleontologists have the opinion, at least the ones I've talked to, of the opinion of we should keep names around. We shouldn't get rid of them. One, because it's kind of like erasing a writer from history, erasing a paleontologist who named something. Erasing their work from history isn't fun. And two, having more names to throw around helps data.
It does kind of help to compare and contrast things, and it helps
Yeah.
avoid mixing up data sets. I guess
Correct.
the big takeaway with Apatosaurus and Brontosaurus, whatever they are distinct animals. Whether or not you want to put that at a genus or a species level will depend on the researcher.
Right.
But at present, it's at a genus level. They're still the closest relatives of each other.
It also
But they are
depends on your
distinct.
opinion.
I believe Brontosaurus is slightly more robust than Apatosaurus, is the main
Yes, because
thing.
Brontos smash specifically Brontosaurus, because Brontosaurus's neck appears to be slightly more robust. Yes.
Yes, and the forelimbs, I think.
Yeah. We do have another question, which is the depictions we've seen. That's a weird.
Yeah, I'll just read it out in full. How close to 100% are these dino depictions that we've come up with based on the bones? That depends on the animal.
That also
Some
depends.
fossils are so high quality, it is just the animal. Let me, like this Camarasaurus, that is almost the entire skeleton. I think it's just missing like part of the hip and part of the tail. Otherwise, that's a full skeleton. We know the proportions, all that.
There is an issue.
Skin texture is still a guess.
Yep.
Like, did it actually have these inflated nostrils? Maybe, maybe not. We don't know. Some things will always be a guess. Some things will be based on solid evidence. Like,
so
Cetiosaurus here is pretty fragmentary. This is mostly filling from related animals.
If you've ever seen pictures from the book All Yesterdays, there's an excellent section in the back of the book which explains why, one, reconstructions, unless we literally find a mummified version of the dinosaur, and even then, will never be 100% accurate. Because one, we don't know color. Two, we don't know anything about like extra little things in our skin. Let's take, for example, a turkey. A turkey. Can you pull up a turkey skeleton for me, Doc? If you don't mind, for this example.
Yes, and then there's something else I want to show.
Also, a lion.
Because there is sometimes when we do know the colors.
I'm aware. That's why I'm saying most of the time. That's why I said if we don't find a mummy, because there are some dinosaurs that we just found the dinosaur, two in particular. But yeah, that's the skeleton of a turkey. If you've seen what a turkey looks like, it's not just that. But with skin wrapped around it. It has fleshy baubles everywhere, feathers everywhere. They're very thick. Turkeys look very fat. The other example is penguins. Penguin skeletons look fucking disgusting. That's because of how their necks are built. Because penguins have really, really, really long necks. Same with seals. But because they have so much like skin, fat, feathers, other things on them, they can look differently. Also, colors. So, or there are a lot of lizards, for example, like pegomastics. Pegomastics have really unique and spiky tails.
Pegomastax is a dinosaur.
No, fuck not pegomastics. Uromastics. Excuse me. Uromastics have really unique pine cone spiky tails. Those aren't shown in the bones. So it all just...
Then for comparison, sometimes we get really lucky.
Yeah, sometimes we just find the dinosaur. So this is
Sinusoropteryx.
Which you can tell based on all the descriptions. Yeah, we know what this thing just looked like.
Yeah. This is the skeleton. I think it's 100% complete, maybe missing one or two vertebrae here and there.
And you can see
we have original color preserved. We have original feathers preserved. It's kind of nuts.
And you can even tell on the tail, we have patterns preserved. This thing had a raccoon's eye mask and a long banded tail.
Yes, I'm trying to get a good picture that shows the tail while But yeah, it has raccoon-style banding.
Yeah. There's also other things, like I believe, for example,
There we go.
Borealopelta or Edmontosaurus, where we have mummies. That I think with Borealopelta, we literally have color. It's why Borealopelta descriptions are also red.
Yes, we have colors and the keratin cones on the spikes.
Yeah. Now, even these may not be 100% correct for a few reasons. One, certain color pigments don't preserve. Specifically, blues, maybe like greens and blues, don't preserve very well. So
here we go.
yeah, so it's why all of like the dinosaurs that we have colors for tend to be red and yellow, because those are the ones that preserve. Because those are I forgot what pigmentation those are. Basically, yeah, that. But even still, God, that's pretty. Sorry, I'm just looking how pretty Borealopelta is.
Yeah, I'm trying to show
But
the full image. Google's
these are
not
very
cooperating
rare.
very well.
These are very rare. I think we have like 5 mummies of any dinosaur. We have 5.
No, we have more than that. We have like a dozen Edmontosaurus.
Well, I'm saying we have 5 unique dinosaurs. Excuse me. And I think 4 of those are notosaurs. So, they're very rare. It's odd. I think the only time there's one more. There's one more dinosaur that we have accurate coloring for, which is Micro.
I guess the point being that sometimes it's more of a guess. Sometimes we have just the animal preserved. It really depends on the dinosaur.
Most of it's a guess, because even ones that we have just the dinosaur for, sometimes you don't have enough of the dinosaur. Dinosaurs like Pelecanomymus and Concavenator, for example. Pelecanomymus especially. We have most of Pelecanomymus, including skin impressions. The issue is that the skin impressions don't show feathers, despite the fact that we know Pelecanomymus definitely had feathers. So
Ornithomimosaur, and yeah.
So it really does depend. We've also lost some of these. We had two really good Corythosaurus, basically mummies, that are now lost at the bottom of the Atlantic Ocean.
Because World War II happened.
Yeah, World War II screwed over a lot of dinosaurs. It's hopefully find more, but there is always the fear with paleontology that the more we find, you may notice this, that as time goes on, less dinosaurs are found every year, and more dinosaurs are named are from fossils in collections being properly identified than people going out in the field and finding stuff. Because we have found most of the good bone beds, probably. The world is only so big, and also part of it's underwater.
I don't know if I'd say that. Maybe in some areas, maybe, but I think there are still good bone beds out there.
There probably are, but there's less of them than what there were because we found them.
So you're saying we should fund submarine paleontology?
We actually do have that. It's not very good because water is not very good for rock. So, but we have found fossils underwater before.
Yeah, found a few actually.
Yeah, but the issue is that because also the other issue is that as the Earth moves, it slowly destroys some fossils because this is how tectonic plates work.
And I'm sorry guys, but I kinda have to go. Do you mind if we wrap up?
Oh, I'm fine. I'm sorry to leave on a dour note, but I don't think we have
one last question then.
We do? What's the last question?
Fans of the game. I've played Trespasser. It's a game.
It's a game. The dinosaur depictions are Jurassic Park depictions, so definitely ahead of their time. But they're also Jurassic Park.
Especially when they're injured, they have the most realistic movement.
Yes.
Absolutely. But
so anything you want to advertise?
There, though, I'll pull up my last tab again. To people out there, I hope you enjoyed, and thank you for watching.
Anything you want to advertise before you go?
Nope.
I'm currently working on a couple shorts, and hopefully they will be out this next week. But I'm going to be busy, so we'll see how it goes.
Yeah, I have nothing planned for next week, but we'll see how it goes. Never stop learning. Enjoy the randomness. We'll see y'all next time.
Yes.
Bye.
Yeah.
Thank you again.
Hey, thanks for watching my podcast or Let's Play. If you want to help support my channel, you can make a monthly or yearly pledge on Patreon, or just a one-time donation on Vimeo, PayPal, or Cash App. For those looking for something to wear, we have some shirts, hats, and other stylish things in our merch store. If you enjoy gaming, you can always follow and sub to me on Twitch. For those who don't want to give money, I have an Amazon and Steam wish list would help the channel out. And of course, just liking, leaving a comment, and sharing this video helps more than you can imagine. And always remember to never stop learning and enjoy the randomness.